Hey folks, I know you're not here today, so we're going to be doing a virtual lesson about the midpoint of a line. Okay, so let's review quickly some of the equations that you should have either memorized or at your disposal for this unit. First one being, we talked about the distance equation, and I'm always going to use the distance equation that has the x1 and x2 in it, because even if we're working from the origin, you don't have to worry about substituting the number 0 in, because it's not going to change your coordinates. So we'll go x2 minus x1 squared plus y2 minus y1 squared. So that's for distance of a line segment, or distance on a plane. That was the title of the lesson. So basically the distance between 2 points. So for today, we're actually going to, instead of finding the distance between 2 points, we're going to be finding the midpoint. So how far is halfway in between those 2 points? What's the coordinate? We also know slope, which is y2 minus y1 over x2 minus x1. And remember that when you're doing questions that involve distance, you already have some of this information in your equation. So you don't have to do a bunch of secondary math on top of it. And now we're going to get into the new equation that we're learning today. So if I were to have a coordinate system, we'll have 2 points there. So we've got point here, this is point A, x1, y1, and this is point B, x2, y2. We don't know what those values are. The midpoint that's going to happen will happen right in between, right in between those 2 coordinates. And the new equation that you're going to be working with today looks like this: capital M, so not little m is for slope, capital M is for midpoint, and all it is it's the average. It's the average of the x's. If you look from here to here, we're going halfway right there. Okay, and the same thing here. If we're going from here to here, we're going halfway to get your midpoint. So we're averaging our x and y values. And the way that looks, and it's going to come out as a coordinate, the way that looks would be you take the 2 x values, you add them together, and you divide by 2 to find an average of 2 values. Okay, same thing with the y. y1 plus y2, divide by 2. There's our new equation for today. So I've been highlighting all of our important equations in pink. That's what we're going to get there. So now let's talk about certain words. So a median. The word median means it's a line that joins the vertex, which is a corner. Okay, so one of the corners of a triangle to the midpoint of the opposite side. Short form midpoint. So median, we're coming from one of the corners of a triangle, and we're going to the vertex, we're going to the midpoint of the opposite side. Where does it look like? There? Okay, good enough. So if we have this triangle, and we want to move from this vertex right here to bisect, so it's going to intersect the opposite line equally, so right through the midpoint. And if I look at this, our midpoint's right about there. So this is the same length as that. This would be referred to as our median. Okay. All it does is it comes from the opposite corner, hits a side, breaks it into 2 points, hits at midpoint. The other term that you need to be comfortable with is this concept of something called a perpendicular bisector. So a perpendicular bisector is a line that cuts through a side of a triangle perpendicularly as well as through the middle. So it's hitting at 90 degrees and it's bisecting. And it's going to look different than a median. It can look the same as a median depending on the triangle, but most of the times, I'm going to say like 95% of the times, you're going to be able to tell what the difference is based on the type of triangle that you have. A line that is perpendicular and it's not clear. Okay, whatever. That's good enough. Okay, so a perpendicular bisector, it's going to hit this line right in the middle, which is like right there. So it's going to bisect, and it's going to hit it at 90 degrees. So that means that if it's hitting it at 90 degrees, it's coming straight up and straight down, like that. Now I'm going to make this green. Okay, hits at 90 degrees. Boom. And notice it doesn't necessarily come from one of the vertices. Okay, this is our perpendicular bisector. If it's perpendicular, what do we know about the slopes? Okay, perpendicular lines, if they hit at 90 degrees, they have negative reciprocal slopes. So you can find the slope of the triangle side length, and then you could use the negative reciprocal to find the slope of what the perpendicular bisector is going to be. And we're getting into that kind of stuff. That's where your brain has to go with this. Bisector will have negative recip slope Okay, so let's do some examples. of the points A, 3 at 5, and B, 11 at 14. So again, we've got 2 points here. It wants to know our midpoint. Okay, so we have to use our new equation that we learned. We've got x1, y1, x2, y2. And now we just plug them into the equation. So proper form, okay, midpoint of AB, and we're saying it's a line segment. The equation from what we did on the other page, x1 plus x2, we're just finding the average of the 2 points. Be careful when you're plugging in negative numbers. y1 plus y2 over 2, and of course I need the example that doesn't have any. So the answer we're getting is a coordinate. So 3 plus 11 over 2. And then y1 is 5 plus 14 over 2. So, a little bit of math. 3 plus 11, 14 over 2, 5 plus 14, 19 over 2. If we had to graph this as a coordinate, I would let you convert it into decimals because graphing fractions is ugly. So it would be 7 at 9.5. Therefore, midpoint AB is 7 at 9.5 given as a coordinate. So we have a new equation, plug your values in, find your midpoint. Not too bad, okay? The next step, next example we're going to do is a wonderful example for tests and quizzes and assessments and exams. Okay. And it just requires you to do pretty much all of the math that we've learned so far in the course, which is a lot of steps, but it's the same game plan every time. I'm purposely leaving some space because we have to dissect this question with the literacy aspect of math. What is it asking us? So I'm going to be making a lot of ugly notes in between. From vertex the triangle short form. Vertices A -3 at 3, B 2 at -5, and C 5 at 2. To determine the equation of the median, that means the equation of a line. And the way we have to answer that is in y equals mx plus b form. So we have to find the slope and the y-intercept of the median in order to be able to answer this question. The only piece of information that we know is that it comes from vertex C. Okay, so let's draw what this looks like. Real quick sketch. -3 at 3 is going to be there. Uh, 5 at 2 is going to be a little bit lower over there. So this is 5 at 2. And then 2 at -5. This is C. Okay, sorry. 2 as the midpoint. So let's make a triangle with the magic of a circle. That. Now the median that comes from vertex C means that it starts here. So this is one of the points on that line. If it's the median, it's going to go through the opposite side right in the middle. So we could find the midpoint of AB to know what that coordinate is. So we're trying to find the equation of this line. Okay. Game plan. In order to find the equation of a line, we need y equals mx plus b. We're going to replace the m, which is the slope, with a number, and we're going to replace the b, which is the y-intercept, with a number. So we have to find those two pieces of information. We know the slope can be found by using y2 minus y1 over x2 minus x1. But the problem there is we only have 1 point. We need a second point. Okay, we need this one right there in order to be able to find the slope of that median. So we're going to have to find midpoint of AB to get our second coordinate. Okay. Once you've done that, we will have something called a partial equation. That's new. And then when we have our partial equation, the only thing that we still won't know is our y-intercept. So we know the m, we know the slope, and then the letters x and y are going to be in. So your last step is to use a known point, plug in, and solve for b. And these are the steps that you're going to be using whenever you have to find a median. This is exactly the same process. So if you memorize this game plan, every time you see a question that says find the equation of this median, you're going to know what to do. So let's do this. First things first. We can't find the slope unless we know the midpoint. So our first step is going to be find the midpoint. So x1 plus x2 divided by 2, y1 divided by 2. So negative 3 plus 2 is negative 1 over 2. And then 3 plus negative 5 is negative 2 over 2. So our midpoint is negative 1/2 at negative 1. All right. Ugly. You don't have to graph it, so I'm not going to change it to a decimal. Okay. Second point, find slope. So we're going to use vertex C in the midpoint. I'm just going to write them down because I forget what I'm going to do. C is 5, 2. Slope of midpoint to C. And C, y2 minus y1 divided by x2 minus x1. Okay, so 2 minus a negative 1 is actually positive 3. Okay, use your calculators all the time. 5 minus a negative 1/2 is like saying 5 plus 1/2. So I have to find a common denominator. 5, I have to change the number 5 to have a denominator of 2. So it's going to be 10 over 2 plus 1 over 2, which is 11 over 2. What's the rule when you're dividing by a fraction? We invert and change it to multiplication. So because this is like it's over 1, you go straight across. 6 over 11. Ugly. Okay, but that's our slope. I can use that now to create a partial equation. So this is a new concept. And the word partial just means I can put in some information, but I don't know some of the other stuff. Okay, so the information that I'm going to put in is my slope, which I just figured out to be 6 over 11. But then I don't know what my y-intercept is. So I have to solve for that. So we're going to plug in the known point. And solve for the y-intercept. So if I go back all the way up and I think about my line, okay, this is my line here. And what's a really nice known point? I've got either negative 1/2 at negative 1, because that happens right there, or I've got 5 at 2, which happens right there. Because this is the 5 at 2 are its whole numbers, or sorry, whole numbers, I'm going to use that. Why would I plug in negative fractions if I don't have to? Okay, you always have a choice here. Pick the easiest of the two. So instead of wherever I see a y or an x, I'm going to plug in those values. So it's y equals, so I'm going to say 2 equals, we're going to keep the slope there. We're plugging in a number that's being multiplied by the slope here at the x. So we have to make sure that when we plug it in into our equation, that it shows multiplication. And then the only letter we don't know is b. So you're going to have to isolate for b in your last step. So that's over 1, there's a little bit of that. We get 2 equals 30 over 11 plus b. We have to get b by itself. Subtract 30 over 11 from both sides. That's going to cancel out. So we get 2 minus 30 over 11 equals b. You can double check this later with your ABC button, but if I'm subtracting fractions, I need to have denominators that are the same. So they both have to be a denominator of 11. So this would be 22 divided by 11 would give us 2. 22 minus 30 would give us negative 8 over 11 equals b. Therefore, equation of median is y equals the slope that we found, 6/11, the letter x. Notice we're going to have the letters x and y in our equation, just like we talked about yesterday with circles. And then the y-intercept, which is negative 8/11. Lots of steps, the same steps every time. Okay, the only other way we could throw your curve here is ask you to find the equation of a perpendicular bisector. So instead of going up and working strictly with the slope that's already given, you'd have to find the negative reciprocal slope of the side that it intersects. And we looked at that on the other slide. Okay, come on. There it is. Good luck.